on the 7-day FDP conducted by RFI on SPSS, the introductory module. Today, I am going to discuss the independent sample status. I'll also try to include paired sample status in today's session, right? Yesterday, I think I said this thing to all of you. So if I talk about previous sessions, so I think again I'm repeating what we have covered so far. So we have covered the descriptive statistics or basics of SPSS, then descriptive statistics, reliability of a scale. Then we have seen the normality of the data. After that, I tried to explain you chi-square test, independence of attributes, and the independence of the attributes, and along with that we have seen the goodness of fit test. Then I tried to explain you one sample t-test yesterday. Today, in the parametric test category, we will go ahead and we will talk about the next family of the t-test. So usually t-test we can say is of two types, one sample and two sample, right? So yesterday we have seen one sample t-test where we were having only single sample, single variable. Now when we are having the two variables, so in that case we can say we are talking about the two samples t-test. So two samples t-test is two samples t-test is basically based on two variables. Now firstly I'll talk about how many types of two samples t-test can be possible for us, right? So there can be two types of two samples t-test. The first one is the independent samples t-test and the second one is the dependent samples t-test. So both I'll try to take one by one. Give me a second. I'm going to share my screen first. I think I shared my screen and my screen is showing you the PPT slides. I hope it is visible. Slides are visible to all of you?
Yes, ma'am.
Yes. So now I'll explain you the independent samples t-test firstly, and then we will go for dependent samples t-test, right? Now, firstly, if I talk about independent samples t-test, yesterday when we were talking about the one sample t-test, we have seen we will having only one sample or one variable, and that should be numeric in type, right? And we can treat that variable as a dependent variable. Now, in case of independent samples t-test, we can say we will having the we can call it as a means some other name of independent samples t-test are the two samples t-test, and sometimes we can also call it as a students t-test, right? So in case of independent samples t-test, we should have two variables available with us. One should we can treat as a dependent and other we can treat as an independent variable. And the purpose of independent samples t-test is also to find the significant mean difference in the dependent variable in context to the categories of independent variable, right? So in the blood points, if you can see, if I talk about the meaning of independent means two unrelated groups, two groups which are not paired with each other. So that groups are known as independent groups, right? Say for example, if suppose in this FDP, if I say there are participants, male also and female also, right? So I can say there are two groups. One group is of male, second group is of female. So that way these two groups are independent to each other. There is no common thing available in those two groups. That way I can say these two groups are independent to each other, or other way around I can say the one unit or the one object or the one person of the one group cannot be the part of other group. That way we can able to maintain the independence type of relationship between the two groups, right? So this is the meaning of independent. Now when I'm saying you that we will have the two variables, right? So we will see which two variables we need to have. So this is the meaning of, or this is the concept. Again I'm repeating for you. Here what we are doing, we are finding the significant mean difference in the dependent variable. Dependent variable means the numeric variable. So we are finding the significant mean difference in the dependent variable in context to the categories of independent variable, right? So this is the purpose of independent sample t-test, that is to find the significant mean difference. So I think first slide I explained you. Is it clear to everyone? Any confirmation? I hope participants have joined, right? Any
Yes, ma'am. It's clear.
Yeah, thank you, ma'am. And now, example you can see, because we are talking about the independent groups. So recently, I think just I have given you the example. For example, gender, that is in this particular FDP, if I say how many of the male participants or how many of the male persons have joined this particular FDP and how many of the female have joined this particular FDP. So that the classification of the gender can be male and female usually, right? So we can call this group as a independent groups, right? Now, talking about the type of variables we need to have for the independent sample status. So as I said, we need to have firstly the dependent variable, and the dependent variable should be continuous in nature. Continuous means it should be numeric variable for us, right? Then we should have the independent variable, and in independent variable we need to have two labels. That means independent variable will be your categorical variable, and in this categorical variable you should have two categories available with you, or two labels or two groups, one in the same meaning, labels, group or category, right? So we will have two variables, one dependent, one independent, or I can say we will having the two variables, one numeric that is continuous and one categorical with the two labels or with the two groups. So this is the basic requirement of the independent sample status. So gender example I have already given you for the independent variable. Other example can be suppose occupation of the respondent. So might be possible I am dividing my respondent into the two categories, business class people and the service class people, right? So on the basis of their occupation, I can say there are again one categorical variable with the two groups or two labels. So this is the meaning of independent variable. I hope this slide is clear to everyone. Is it okay?
Yes, ma'am.
Yeah, fine. Thank you so much, ma'am. Moving about for the next slide and talking about the sample size, I think those who are knowing research methodology or those who have studied statistics, they are knowing or research methodology. Those who have studied, they know generally. Generally, when we are going for the t-test, it is written in the books when the sample size is less than 30. Usually, we should apply for the t-test, and when sample size is greater than 30, we will go for the z-test. But because of the central limit theorem says that when we are increasing the size of the sample from 30 and 30 onwards, so if you're in that case, your data shows the normal distribution, and this is the basic requirement of the t-test and the z-test. So that is why we can say t-test will be behaving like z-test in such cases, right? So that is why many of the softwares are based on the t-test, because generally it says when the sample size is increasing from 30, so data shows the normal distribution. And we can say because the I think yesterday probably I said this thing, that when we talk about the t-test is generally used when we are knowing this thing, that the standard deviation or the variance of population is unknown. And as I say, in many of the cases generally it happens we are not knowing our population in a better way, so that way it is difficult for us to collect or find the standard deviation or variance of the population. So this way generally t-test is getting more preference over the z-test, right? So this is the concept of sample size. Talking about the hypothesis, how we need to formulate the hypothesis, although yesterday also we have seen this slide. So again, in case of independent sample t-test, we need to decide upon whether we are going for the one tail t-test or two tail t-test. If we are talking about one tail t-test, in that case you can go for the row number this 2 and 3. And if I talk about the one two tailed t-test, in that case we will go with the one serial number 1 row, right? So we can say null hypothesis states that we
Uh,
want
I have one question. The number of tails means that the box which have upside and downside both the lines. So this shows your number of tails.
this is these are in case of two tailed test, your rejection reason falls on both the tails.
Okay, if it is one side, then it is one.
It will
If it
fall
is
on the
both of the
one tail
sides, then
only.
it is two.
It,
Okay, fine.
yeah, yeah. So generally, when you are saying means in word form, if I'm saying there is no significant difference, that is your null hypothesis. But when you are saying there is a significant difference, means you are not sure the difference is greater than or less than. That means you are saying there is a significant difference, but we are not clearly stating that case. That is a case of two-tailed test, right? So you can see here symbolically we have written mu1 is equals to mu2. That means both the population means are equal. And here we are saying mu1 is not equals to mu2. That is, both the population means are not equal. That means this is a case of two-tailed test, right? Talking about the next, when I'm saying mu1 is greater than or equals to mu2, that means first population mean is greater than or equals to second population mean. Alternatively, I'm saying first population mean is less than second population mean. So when I'm clearly stating my alternative hypothesis by mentioning less than and greater than, that means this is a case of one-tailed test, right? And in such cases, your rejection reason will fall on either of the tail, either on the left side or on the right side, right? So this is the way of representing or writing your null and alternative hypothesis in case of independent sample t-test. Is it okay?
Ma'am, mu1 is greater than equal to mu2. And second case, null hypothesis is, then alternative hypothesis will also be mu1 is less than equal to mu2, no?
Sorry.
Uh, Ma'am, जब null hypothesis दिया है mu1 is greater than equal to mu2 second
Yes.
case में, तो alternative hypothesis भी mu1 is less than equal to mu2 होगा ना?
How come it is possible when I'm saying it is greater than and equals to? When I'm saying it is equals to, how it can be equal to either here? It
Okay,
is not
okay, okay,
possible, right?
okay, ma'am.
Yeah. So that is why we are stating this thing, that alternative hypothesis is directional and it is very clear, which is clearly stating that your both the population mean are means either of the population mean is greater than or less than, not equal to. In such case, this is a case of one-tailed test hypothesis, right? And in such case, your rejection reason fall on either means it will fall either on the tail, either on the left or either on the right tail. So this way we can say symbolically we can represent the hypothesis of independent samples t-test. Further, talking about the hypothesis in the word form. So I think it is now quite clear. I can clearly say there is no significant difference in the group 1 mean or group 2 mean, or I can say group 1 mean is significantly less than or equal to group 2 mean, or I can say group 1 mean is significantly more than or equal to group 2 mean. So this way, these are the formations of your null hypothesis in case of two-tailed, and remaining two are of the one-tailed test. Is it clear in the word form? Is it fine? May I proceed?
Yes, ma'am.
Yes. Now, other way around, we can also write our hypothesis like this. This might be in the papers. Maybe you have seen that mu1 equals to mu2 and mu1 is not equals to mu2. That means two population means are equal, two population means are not equal. Or I can say mu1 minus mu2 is equals to 0. It is quite obvious when both the population mean are similar. So that means the difference will be 0. And when both are not equal, that means the difference will not be equals to 0. It will be some value, maybe positive or negative, but it should be some value for us, right? So this way we can represent the hypothesis in this form also. Moving ahead, talking about the steps for the manual procedure. So yesterday I said usually manual procedure, we are saying this is a manual procedure, but usually when we are using softwares also, even then we are following almost the similar procedure which we are following in the normal manual cases, right? So here firstly we need to define our null and alternative hypothesis. We need to set the level of significance, that is alpha value. We need to decide upon, or we need to calculate the degrees of freedom. We need to state the decision rule. Then we need to calculate the t statistic, and then we need to state the results, and we need to state the conclusion. So you can see when I say degrees of freedom in case of independent sample t-test, the formula of degrees of freedom is n1 minus 1 plus n2 minus 1, or I can say n1 plus n2 minus 2. right? This would be the formula for degrees of freedom. Clearly, we are saying when our calculated value is less than tabulated value, so we are going to accept the null hypothesis. This is based on the calculated and the critical value. But other way around, if you want to state your decision rule on the basis of p-value, that also we can do. Talking about the t statistic formula for in case of independent sample status, so this formula is t is equals to underscore or under root of x1 bar minus x2 bar divided by sp square in brackets 1 upon n1 plus 1 upon n2. So where sp is the pooled standard deviation or pooled variance, I must say. This is the pooled variance, right? So formula for pooled variance is this. That way we can calculate if we want to calculate the t value manually, right? Degrees of freedom many a times varies also when your that assumption of the equal variance. I'll show you in the upcoming slides. There are certain assumptions also we need to follow in case of independent sample status. If variance is not equal in the groups, in that case, degrees of formula will be this, and this will not be the formula, right? Although we do not need to do all these exercises manually, as software we are using here, so the software will give us the specific figures for us, and that way we can conclude the outputs or results, right? I hope this slide is clear. Any doubt? Any confirmation? I hope you are listening to me. I think it is difficult in the online mode to understand whether people are listening to me or not. Is it okay? May I have switched to the next slide?
Listening, ma'am. Yes, ma'am.
Yeah. Okay, thank you. Moving ahead, talking about, I think yesterday also I have shown you one t-test table. Here also we can see we are having the t-test table. So say for example, for explaining you how we can use the t-table, suppose we are talking about calculated value. That means using the formula, if you have got the t value, that is the calculated value. And if suppose it is coming as 1.78, and suppose we are using the alpha value as 5%, and again suppose we are taking the degrees of freedom is 12. So in that case, you can see you need to find the degrees of freedom in the first column, which is this 12, and alpha value is 5%, that is this 0.05. So the intersection point of these two will give you this t figure, that is 2.179, and that way we can compare the calculated figure with the critical figure or the tabulated figure. So it is quite clear that calculated value is less than to the tabulated figure. In that case, we are going to accept whatever is our null hypothesis. So this is only for an example. I explained you that how you can see the critical or the table value using the t table value, right? Is it fine?
Yes, ma'am.
Yeah. Now talking about the assumptions. So this is the very imperative and necessary thing to understand, that what are the assumptions which we need to first test before applying the independent sample status. So the first assumption says the independent variable should be categorical. That means it should be either nominal or ordinal. If this variable has 3 or more categories, we must decide before running the test that for which categories we want to compare our independent variable, right? That means here, if I want to say simply this particular assumption, this assumption says we need to check which type of variable we are having, the independent variable. If that variable is categorical, it is fine. Now we need to check how many categories we have taken there, whether there are 2 or more than 2 categories. 2 categories means it is fine, but if we are having more than 2 categories, so in that case we need to decide upon in which 2 categories, for which 2 categories we want to compare our dependent variable, because this is the limitation of t-test. T-test cannot compare more than 2 categories or more than 2 groups, right? So this is the first assumption. Second assumption says the dependent variable should be continuous. Means whatever is your dependent variable or second variable, it should be continuous or numeric. Third says there is independence of observations. That means whatever observations we are taking in the data in both the groups, they should not be connected with each other. So that way we need to check. Means from if I want to simplify this thing, I can say we need to collect the data from every person only once while collecting the data. Fourth says the dependent variable should be normally distributed in both the groups. Means whatever are the two groups or two categories of the independent variable, in that we need to check that the dependent variable should be normally distributed, right? Then further we need to go upon and check whether there is any significant outliers available in the dependent variable. And lastly, we need to check variances of the dependent variable in the two groups is equal or not. Or other way around, we need to say, or we can say that we need to check the homogeneity of the variance for the dependent variable in both the groups. So this way, these are the 6 assumptions which we need to check before performing the independent sample t-test. So out of these 6, you can see first 3 you need to only observe, and by observing we can make them or we can achieve them, we can meet them. But for the remaining 3, we need to take the help of our software, and that way we can find these or we can check these assumptions for the independent sample status, right? So I hope assumptions are clear to everyone. Any doubt? Any doubt? Oh. Any doubt?
No, ma'am.
Okay, fine. Thank you, sir. Now, usually this is known when assumptions are not meeting by our data for independent sample t-test. So suggestive is we generally do not need to apply the parametric test, and we need to move for the non-parametric test category. And for independent sample t-test, we have a non-parametric test under this category named as Mann-Whitney U test, right? So instead of applying independent sample t-test, we should go for the Mann-Whitney U test. Now, I think yesterday also we have seen this particular graph. This graph we are using for testing the normality of our data. And if such type of graph or histogram we are getting for our data, we can conclude that the data is normally distributed. Further, talking about the Levens test hypothesis says that the variance in both the groups is equal, right? Either we are talking about first group and second group, in both the group variance is same or equal. Alternatively, we are saying the variance is not equal. This is the Levens test, or we are using the Levens test to check the homogeneity of the variance. So this output we are not means this particular test we cannot directly apply. Once we will apply the independent sample t-test, in that particular output only we need to check whether our data is meeting this particular assumption or not. Now, how to apply independent samples t-test in SPSS? This is the process. I think the process we will see once we will go in the SPSS. So I think this is the conceptual aspect of independent samples t-test. If you people have any queries so far, you can please ask me, or if not, we will move for the applying of independent samples t-test. Yes. Any queries so far? No queries? Shall I proceed?
Yes, ma'am.
Yeah, thank you, sir. Okay, now we are coming to the sheet which I have already given to every one of you. I hope you people have downloaded the sheet from the WhatsApp with the name employee data. I hope you people have downloaded it. Yes?
Yes, ma'am.
Yeah, fine. Thank you, ma'am. Now, you can see there are so many variables available in this particular in this particular sheet, I need to check, I need to decide upon two variables here. So suppose I'm taking the gender variable and I'm taking the salary variable. I want to check whether there is a significant difference in the salary of male and female, whether this difference is existing or not. This is what I need to check it, right? So now, firstly, just a minute, give me a second. Yes. So here I'm writing hypothesis will be, can anyone tell me what will be the hypothesis if we are considering salary and gender? Anyone? Any attempt?
Ma'am, there is no significant difference in the mean salary between male and female.
Between
Male and female.
male and female. Yes. Very good. Very good, sir. There is no significant difference in the mean salary of male and female employees. I think, is it okay? Is it fine?
Yes, ma'am.
Then alternatively, I can say there is a significant difference in the mean salary of male and female employees. This way we have formulated our hypothesis, and suppose we want to check this hypothesis at 5% level of significance. Is it okay? May I proceed now? I hope you people have noted down this.
Yes, ma'am.
Yes. Right. Now you can go. I think rather than telling you this, I directly tell you, and then we will check that thing, right? So now to perform independent samples t-test in SPSS, you need to go to the analyze menu. Then you can click on the compare means, and then you can select upon independent samples t-test. I repeat, go to the analyze menu, select compare means, and then select independent samples t-test. So may I select this?
Yes, ma'am.
Yeah. Now, once you are selecting this, it is asking you to provide the variables at the right hand side. So you need to select the current salary, which is named as salary. You can shift your current salary in the test variables box. You can shift the gender in the grouping variable box, right? Done. Is it fine?
Yes, ma'am.
Now you can click on the define groups. Here, I think you have not checked, but I know it is defined as M and F. For male, it is M. For female, it is F. And then you can press on continue. Once you will complete this process, you can go to the variable view and you can check value label column. It is defined there, right? You can press on continue. Then coming here, selecting the options, you can select, you can check here confidence interval percentages is 95%, right? That means we are testing the hypothesis at 95% level of confidence, but that means the 5% will be the level of significance, right? So we want to check a hypothesis at this particular level only, but if you want to make any changes, you can use your keyboard and can make. I think I'm okay with it. I'm pressing the continue button. I think all things are set here. You need to only click on OK to generate the output. So may I click on OK? I hope everyone has got the same. May I click?
Yes, ma'am.
Yes. Once you will click on OK, you would be able to get your outputs in the output viewer window, right? May I start explaining the but I think we have done one mistake. Can anyone tell me what? Anyone can tell me what we mistake we have done? Anyone? Yes, what thing we have not done correctly? We forgot to check our assumptions, right? Right?
Yes, ma'am.
Yes.
Yes. So, shall I firstly tell you the procedure of testing the assumptions, and then I'll explain you this output. Is it fine?
Yes, ma'am.
Okay, fine. Good. So now, as you can see, we are having two variables with us. One is gender, second one is salary. Gender is a categorical variable, we know, and it is having only two labels, that is male and female, and we are having one numeric variable, that is salary. So I think these assumptions we have checked already. We are assuming that from each employee we have collected data only once, so that way we are meeting with the third assumption, independence of observation. Now, for checking the remaining things, we need to go to the analyze menu. We can click on the descriptive statistics, and then we can click on the explore button. So I hope I can click on this. Everyone has found this particular option, right? May I?
Yes,
May I?
ma'am.
Yes. Now you need to shift your current salary into the dependent list box and the gender into the factor list box. Because if you can recall the assumptions, let me show you. Assumptions were this, right? So assumptions were like this assumption says we need to check the dependent variable should be normally distributed in both the groups. So that is why we have shifted the independent variable into the factor list box. Is it okay? Clear to all? Fine. May I proceed now?
Yes, ma'am.
Now we need to right click on plots. As we have already seen in statistics, we do not need to touch anything. We need to only click on the plots. Factor labels together. That means if we will go with this, so in the same box, two box plots will come, one for male and second for female, if we are going with the first option, right? So I think usually this is good to compare the things. We will go with the by default option. We will deselect stem and leaf, and we will click on the histogram. And then we will select normality plots with S. This is all you need to do, and then you can press on continue. So may I hope people have performed this. May I click on this?
Yes, ma'am.
Yes. Now you need to only click on OK to get the outputs. I think it will take few seconds. Anyone who has got the output?
Yes, ma'am.
Okay, that's great, man. Probably your processor is very fast. My processor is taking time. Yeah, I have also got. Thank you. Now we can check. The first table is the case processing summary table. Here we can see for the current salary, this is our numeric or the continuous variable. Gender is a categorical variable with the two categories, female and male, right? Total of the female is 216. Total of the male is 258. So there is no missing value in the data. So total is same, like the sample size. Coming to the descriptives, you can find here For both the groups, that is for female and male, we are getting the descriptive statistics. Means for gender is divided into the two groups or two categories, and for both the categories we are getting these descriptive statistics. So we can look at the mean. It is around $26,031.92. This is the mean salary for the females, right? Similarly, these are the confidence interval for mean. These are the intervals, or these are the ranges at 95%. 5% trimmed mean says $25,248 would be the mean salary for the female if we are removing the outliers. 5% from both the sides. Median figure is $24,300. Variance is a very large figure. Standard deviation is around 7,558. Minimum of the salary is 15,750. Maximum is $58,125. Range is, I think I already told, this is the difference of maximum and minimum. So it is $42,375. Interquartile range is the difference of third quartile and first quartile, which is 7,013. And skewness is 1.846 and kurtosis says 4.641. Right? This is the case of female salary. In case of male salary, we can read these figures and we can compare mean and median. So mean and median, there is a large gap in the values. There is a very very much difference existing in the median salary and in the mean salary. So that way, as yesterday I said, in context, may I continue? Yeah. So now we can say we are looking at the median figure and the mean value. We can check there is a difference in these figures. So means according to the characteristics of the normal distribution, there is a problem in the normality somewhere if we are talking about mean and median, right? Similarly, looking at the skewness figure and the kurtosis. For skewness, I have told you the threshold value is plus minus 2. So this value is coming in this range, and kurtosis value is plus minus 3, which is also coming in this particular range. So that way we can say for male, the salary can be somewhere normally distributed if we are looking at skewness and kurtosis. But for female, kurtosis value is very high. It is not coming in plus minus 3 figure, right? Talking about the normality using the Shapiro-Wilks test, we can check the significance value is less than 0.05. In that case, we cannot accept the null hypothesis for the Shapiro-Wilks test. And can anyone repeat what will be the null hypothesis for Shapiro-Wilks test? Yes? Anyone?
Variables are normally distributed.
Very correct. Very good. This is the hypothesis, and we are not accepting the hypothesis, right? Neither for the female, neither nor for the male. So that way we can conclude that probably there is a problem with the normality of the salary of the male and female both. Means salary is not normally distributed as per these figures, right? Going ahead, talking about the histogram. Histogram is also stating or showing the same story. We can say as the salary is going higher, we can find here very less number of people, those who are availing these kind of salaries, right? So that means your data is positively skewed data, right? Higher salary is not obtained by so many of the employees in the organization in case of female. Talking about the male salary, so the salary for the male is also showing the same picture using the histogram, that there are very less number of male who are availing the higher salaries, right? So that means your data is positively skewed data, because once you will put a bell-shaped curve on your histogram, that would be positively skewed, right? I think I can show you. Yesterday also we have performed the same thing. There is no big rocket science now using the SPSS. I think every one of you can also do the same. You can check the length or the size of your tail in comparison to your left tail, right? It is very, very large. That means your data is not normally distributed. It is positively skewed for male and female both. Is it clear to all?
How we say, ma'am, it is positively distributed? Will you please tell me again?
Sorry,
How it is that equally distributed the income? Will you please tell me again?
how it is equally distributed?
Yes, as you say, na, the income in male and female, it is that the proportion maximum the earning is 25,000 to 50,000 in between, and then the lesser people are getting salary which is higher.
Less
So
number of people are getting higher salary, right?
yes, 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 yes.
Yes. Then
So how we calculated that it is positively distributed or negatively
I
distributed?
think, yeah, I think you have attended my previous session, sir. When I was discussing normality, have you attended the session?
I attended, but I have little bit confusion in that.
Okay.
That's why I'm
I
asking.
think looking at the tails, you can see, if I talk about the tail, I think you know the component of bell-shaped curve. There is a this thickness in the bell-shaped curve, and there are two tails, right? If I compare
Yes.
left tail and right tail, you can see the right tail is very high in comparison to the left tail, right? So when the right tail is greater than the left tail, we can say data is positively skewed. Or if not, you are not understanding this, you can see your skewness figures and kurtosis figures, both are positive. If these figures are positive, that means your skewness or your data is positively skewed data, right? Similarly, coming to the female data, you can check female skewness, for female salary skewness is also plus, right? So that way
Yes. Yes.
also this says that your data is positively skewed data, right?
Okay. Fine.
Yeah.
Excuse me,
Thank
ma'am.
you, ma'am.
How do we get that bell-shaped curve, ma'am?
Okay, sir, you need to double click on the area of your graph, right?
Okay.
Once you will double click, you would be landed on the chart
Okay.
editor. From here, you need to select from the lower bar, you need to select this curve, this show
Okay.
distribution curve, right? And then you
Okay.
need to close only. And
Mhm.
again, you can close this editor. You would be able to see the normal distribution curve on your graph.
Okay.
Fine?
Thank you, ma'am. Thank you, ma'am.
Yeah. So this way we can say there is some issue with the normality of our data, right? And looking at the QQ plot also, we can see this curve is at the left hand side. That means this shows our data positively skewed data. This is the QQ plot for the females, right? Now QQ plot for the male also, you can see this curve is going at the upper side. That means your data is positively skewed. Now talking about the box plots, you can see we are getting the two box plot, one for female, second for the male. As the range is very small, female are getting the salary in between this particular range. That is why the size of the box is small here. Here you can see this is the males are getting higher salary in comparison to female. So that is why these whiskers are going till here also, right? So now looking at these two, we can find there are some outliers which are already available in the data. Some of the asterisks we are getting for the female salary, and here we are getting only single asterisk for the male category. So somewhere we can say there are significant outliers available in the data. So if we are looking at the assumptions of the independent sample status, that way we should not report the independent sample status result in our researches, right? But still, for the sake of understanding what these results are saying to us, we will conclude the results which we have got previously using the independent sample status. So now I again came back to the previous output of the independent sample status. I hope I can explain this now. After checking the assumption, I think now I'm on this. May I? Okay. Is it okay? May I start explaining this?
Ma'am, just a second, ma'am.
Okay.
Actually, the same I have performed, but for me it is showing error, ma'am. The independent sample table is not produced because T cannot be computed because at least one of the groups is empty.
Okay. In that
So
case,
I could not get the
have
result
you
table, ma'am.
defined here, ma'am, have you clicked on this button, define groups? Have you written there
Yes, ma'am.
MNF?
Yeah, yes.
In that case, there should not be a problem. If you're not defining this MNF, in that case, there would be a problem.
No, I have done, ma'am, because if I go back to the data view, it is showing male, female also,
No, no,
which
not
means
data
I
view,
have done.
not data view, ma'am. Here
Okay.
you need to define. Once you are performing this test, right? Here you need to define. Say,
Okay.
for example, I'm sending it back, right? Again, I'm shifting it to the
Okay.
grouping variable box. Now you can see this
Okay.
button is active. You need to click on this, and here you need to pass M and F, and then you need to press continue.
Can you show me one more
Yeah,
time, ma'am?
yeah,
Sorry.
yeah. You need to click on the define groups. You need to write here M and F,
Okay.
and then you can press continue, and you can press OK. So I think the results will be generated now.
Okay,
I'm
ma'am.
not,
I'll do it again.
yeah, I'm not pressing OK because I already got the output. You press and tell me, please.
Okay.
Yeah,
Thank you, ma'am.
yeah. Have you got the output, ma'am? May I start explaining now? Nitya, ma'am?
Yes, ma'am. No, ma'am. Still, it is showing the same.
Okay. Which version of SPSS you are using?
Actually, I don't know, ma'am. I've been having this for a
Okay.
long time,
Is
but
it
not
possible for you
using
to
it.
share? No problem. Is it possible for you to share the screen?
Yeah, yes, ma'am. I can.
Give me a second. I'm stop sharing my screen. Just a minute.
Okay.
Yeah, I did. Now you can share.
Hope you can see, ma'am.
No, right now not. Now I can see.
So here the test result shows like this.
Just a minute, ma'am. Can you do one favor on me? Can you perform in
Yes.
front of me?
Yeah, yes, ma'am.
Yeah.
Yes. So if I go to analyze, compare means, and independent sample
Yes.
status.
Yes.
So here, if I do gender
Yeah.
to the grouping, and
Yes.
here define male,
It
female,
should be a
and
small f, ma'am. Probably maybe a problem of
okay,
capital, maybe.
okay, ma'am, I'll try
Yeah.
that.
Yeah. Continue. Then press OK.
Yes, ma'am. Got it now.
That means it is a case sensitive software, right?
Yeah. Yes, ma'am. Thank you so much, ma'am.
Most welcome, ma'am. Okay. Okay, I shared my screen. I hope my output is visible to all. Right? May I start explaining the output now?
Yes, ma'am.
Now you can see the first table says, I think this is, I have already explained that here we are having the numeric variable salary, we are having the gender as male and female, we are having the number of respondents for male and female, and then we are having the mean salary for male and mean salary for male, right? Standard deviation of the salary for the male and female, and the standard error of mean for male and female salary. Now, looking at the last table, that is independent samples T table, here we will check the last assumption of the t-test, which is the homogeneity of variance. So you can see the first section is talking about the Levens test. So this Levens test we are using for checking the equality of variance, right? So I think I have shown you the hypothesis also. Levens test hypothesis says that the variance is equal, right? This is the null hypothesis. So looking at the significant value for the F, we can find the significant value is less than 0.05. That means we can reject the null hypothesis. That means the conclusion goes that the equal variance is not assumed, right? Because we are rejecting the null hypothesis of the Levens test, right? So that way we will not report the results or output of the first row, and we will go in the second row, that is equal variances not assumed, and we will report the results of this particular group. I hope this is clear to everyone. May I explain further?
Ma'am, will you please repeat it again?
Okay, here you can see the hypothesis for Levin's test was the equal variance assumed, right? Or variance is equal in the both the groups. This is the null hypothesis, right? Looking at the significant value of the Levin's test, which is 0.000, which is less than 0.05. So if p value is less than 0.05, in that case, we are going to reject the null hypothesis, right? So we are saying that equal variance is or variance is not equal in both the groups. That means first line says equal variance assumed, right? But our result says equal variance cannot be assumed, right? So we do not need to result or report the results of the first row. Rather than reporting the results of first row, we will move to the next row. Equal variance is not assumed. Is it clear now, sir?
Yes, ma'am.
Yeah. So you do not need to pay attention on the first row figures now. We will only see the figures of second row. Sorry, against the equal variances not assumed. Here you can see the t value is 11.688 and the degrees of freedom is 344.262, right? And the significant value is point triple zero. So this significant value is less than 0.05, right? It is quite clear. So we can reject the null hypothesis. And if we are rejecting the null hypothesis, you can see our alternative hypothesis was we will conclude there is a significant difference in the mean salary of male and female employees. Is it okay? Is it okay?
Yes,
Yeah,
ma'am.
yeah, yes, ma'am.
Yes. So
Ma'am,
this way, yes. Any doubt? So this way, this is an independent sample status. Now further, if we want to say whose salary is higher or whose salary is lower, right? So then in that case, you can see the main difference is or the main value is coming as 41,000 something for male, and for female it is 26,000. So it is quite clear that the average salary of males are more in comparison to the female employees, right? So that way, this conclusion also you can draw from here, because difference is coming as significant difference. So you can say males are drawing higher salary in comparison to the females or more mean salary. Is it fine?
yes, ma'am.
Yes. Now, I think this is about the independent sample status. Now I'll explain you the next test, that is the paired sample status. So I hope I can explain that. No doubt so far now in the independent sample status. Any confirmation?
Yes, ma'am, we can proceed.
Yeah, thank you so much, ma'am. So I'll show you now the paired sample status slide. I hope slides are visible to everyone.
Yes, ma'am.
Yeah. So now I, as I say, there are two types of t-test, one sample and two sample. One sample yesterday we have seen, both the two sample status today we are looking. First we have already seen, that is independent sample status. Now I will talk about paired sample status, right? So but from the name, I think itself it is very clear. Paired samples means where there is a pairing in the samples, that is the paired sample status. And this pairing usually is possible when we are keeping the same sample in both the groups, right? So generally, when we are meeting the conditions like pre and post, before and after, so in that case, means when there are certain time intervention is there. So first thing I'm conducting today, after some time I'm conducting second thing for the same group of people. That way this is known as paired sample status, right? So that means the logic behind paired sample status is that we will use the same sample twice for the means on the different time intervals. Say for example, I am suppose talking about this FWP, please do not mind. My purpose is my interest is do not is not to hurt anyone. I'm only saying this thing. Suppose for example, I want to see your knowledge level for whatever test I'm teaching in this particular FDP. So, for example, for all the participants, I have conducted one quiz, right? I have taught for the 7 days. and at the end of the 7 day I have again floated the same quiz for all of you. Means same number of people are giving the same quiz, right? So that way I can see the difference whether now there is change in the understanding or knowledge level of the participants or not, right? So that way this is a case of paired samples t-test. Or maybe any company which is giving a training to employees, so that way company is jotting down the performance of the employees and then giving the training, and after the performance of the employees after the training, company has again observed their performances, and then company can compare the performance whether the training was significant or not, whether has training has impacted their performance or not. So this type of things we can come or keep under the paired samples t-test. So this is the logic behind paired samples t-test. I hope logic is clear.
Yes, ma'am.
Yes. Now, talking about the assumptions, so there are only 3 assumptions which we need to check upon. The first one says the dependent variable is continuous and it is measured twice on the same sample of the subjects, right? So this is already we have seen in the conceptual aspect. We will take a continuous or numeric variable, and we need to what we need to do, we need to measure the same sample twice for the same variable, right? As I said, we want to check the knowledge level of the participants, so I'm checking the knowledge level twice for the same group of people. So this is the first assumption. Second says the differences between the scores of the variables are normally distributed. So whatever is the difference come for the scores, we need to check that difference should be normally distributed, and then we need to check the differences between the scores of the variables do not have any significant outliers. So whatever will be the difference coming, we need to check whether there is any significant outliers available in that or not. And then this way we can formulate our hypothesis. I think this way we can say, generally in the more easier way I can say, the hypothesis can be there is no significant difference in the dv, right, before and after the 2 conducts. That would be the paired samples t-test hypothesis, right? Looking at your LOS, you can check your hypothesis at 5%, 10%, 1%, whatever percent you want to consider. So what you need to generally report in case of paired sample t-test, or for in case of generally for all the tests, you need to report generally the test value, degrees of freedom, p-value, mean difference, and you need to report the confidence interval of differences. Generally, these 5 things we need to report in the research papers, right? So this way, I think this is a conceptual aspect of the t-test. Now, paired samples t-test. Now, I expect everyone to open the next sheet. I think I forgot to open that. Give me a second. Yeah. I think math test I have given you, right?
Ma'am, I didn't get this sheet. Can I have it? Will
I
you
think it
please
is
share?
available on the WhatsApp, sir. Are you there
Okay.
on WhatsApp?
Yes.
It is available there. I think I shared both the sheets. Can
Okay.
anyone
Okay.
confirm me whether I shared or not?
Yes, ma'am, I'm
Yes.
available.
Yes, yes. Thank you, ma'am. Sir, I think you can get it from there, right?
I'm checking, ma'am.
Yeah.
Wait.
Ma'am has shared at 4:55.
Yes, approximate, right? I think after that there is no conversation also in the group. So I think it will be easier for you to find, sir.
I got it, ma'am. That is mathstest.sab, na?
Yes, yes, fine. Correct.
Yes.
Yes. So shall I start? Have you opened it?
Not yet, ma'am, but you can start.
Okay, thank you so much, sir. Now, here there are means there are 4 columns although, but I'm considering only first 2 column, and second 2 column you can use for your purpose. This will be a practice kind of thing for you, right? Now I'm talking about the grade 1 and grade 2. Suppose it is again, suppose in a class I have conducted the test twice for the students. So this is the score of the students before teaching them. This is the score of students after teaching them. So that way I want to check whether there is a significant difference in the grades or not. This is the purpose of mine, or I want to check whether my teaching skills or whether my teaching is effective or not. This is what I want to test here. So firstly, what I need to do, I need to find the difference in this course. As you know this thing, as I said during the assumptions, firstly we need to calculate the difference, and then you will check normality. Yes.
मैम ये टोटल में हमारे पास 359 है मैम ना, एंड बिफोर एंड आफ्टर का टोटल स्कोर नहीं है मैम इसका।
Sorry.
मैम टोटल जो है ना ग्रेड 1 ग्रेड 2 में 359 है ना मैम।
Yes, sir. That is a different question, sir, altogether. So in that case, might be possible data will be less for you, right? This data is different. This data is different. There are two problems. One problem is related to the improvement of the scores or grades of the student. Second is the improvement of the weight or a decrease, sorry, decrease of the weight. Suppose the people are taking some diet program. So these are the weights before the diet, before the taking the diet program, and these are the weights after taking the diet program, right? So two questions are very different. So might be possible the values are different, or the observations are less in number. Okay, fine.
ओके मैम।
Yeah. Now, talking about, again, I'm coming back, we are talking about the assumptions. So we need to calculate the difference firstly, right? So you need to go to the transform menu for calculating, for transforming your data first, right? So we are transforming our data here. So I am clicking on the transform tab or transform menu and selecting the very first option, compute variable. Done. I hope everyone has found it. May I start explaining this?
Yes, ma'am.
Here under the target variable, we need to give the name of our target variable. I'm writing here difference. Up to you, whatever name you want to give. It is not necessary. You need to follow the name I have given. You can pass or write anything, whatever you want, right? So the difference should be equal to what? I'm coming here and I'm shifting the grade 1 to the numeric expression box using the arrow key and selecting here the minus sign as I want to find the difference, and then shifting grade 2 here. That's all. Only this calculation we need to perform. That's all. And then you can press OK. So may I? Any confirmation? May I press on OK? I hope you have got the way of getting the difference.
Ma'am, how to go to the complete variable? We have to select the
Transform tab.
analyze.
Under the transform tab, you get it, sir. Have you got it?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, fine. So difference target variable name you need to write here, and you need to only shift the grade 1 and grade 2 by separating them with the minus sign. And then you can press on OK to generate the difference. So may I press on OK? Okay. So once I'm clicking on OK, you can see the output viewer of the SPSS is giving me. This is executed. You can come to your sheet and you can find at the last we are getting the new column with the name difference. Whatever name you have given, that name you can see here. Fine. Is it okay?
Yes, ma'am.
Now, what you need to do, you need to check the normality of this particular column, and also you need to check whether there are any outliers or not. So I think it is now easier for us. We can go to the analyze, we can go to the descriptive statistics, we can select here the explore, we can shift the difference from here to dependent list box, we can click on plots, we can select the histogram if you want to generate, or if not, we can go with the normality plots with test only. And this is all you need to press on OK. So I hope I'm ready. I think I'm ready. May I press on continue?
Ma'am, how did you get explore plots? Okay, got it.
From analyze, descriptive,
Yes.
and then. So is it fine? May I press continue?
Yes, ma'am.
Okay. Then I am pressing OK to get the output. Yes, output is generated. Usually, you can see the mean and the median, they are close. Then talking about skewness and kurtosis, they are in the range somewhere. So I can say probably the data is normally distributed or the difference is normally distributed. Looking at the Sapir-Whorf test, significant value, which is 1.08, which is greater than 0.05 this time, right? So that means we can say the difference variable is normally distributed. Is it okay? Fine.
Yes, ma'am.
Now, histogram is somewhere also stating the same story. To looking at the QQ plot, so most of the data points are following your trend line. So somewhere looking at the QQ plot also, we can conclude that the data or the variable is normally distributed. Talking about the talking about the box plot, you can find the box plot means beyond the upper whisker, we can find there are only three dots available or three circles available, and these are circles and not the asterisk. So somewhere we can say these are not the significant outliers, right? So if asterisk is coming, we can call them as a significant outlier. Otherwise, in SPSS, these are the normal outliers, and we can go with it. Although these are only three in number, if still you want to drop them, that you can do by your own, right? So this is the way of checking the all the assumptions of paired samples t-test. Now I think I'm all set to perform paired samples t-test. So I hope I can go for the performance. Is it fine?
Yes, ma'am.
Okay, fine. Now what you need to do, you need to go to the analyze menu. You need to just a minute. You need to go to the compare means. You can go to the paired samples t-test. I think it is easier to find now. Have you found it?
Ma'am, will you please repeat it?
Repeat. Go to the analyze, select compare means, and then select paired samples t-test. So may I click on this?
Yes.
Now this box is coming of the paired samples t-test. What we need to do, we need to shift the first variable, that is grade 1, in the variable 1 box, grade 2 in the variable 2 box. And then nothing you need to do. Options is saying you the confidence interval percentage. If you want to make changes, you can do, or else we are all set to generate the output. You need to only press on OK button. So I hope, may I press on OK?
Just a second, ma'am.
Okay, I'm waiting.
So I have to select first variable grade 1 and then grade 2, right?
Yes. So may I press on OK?
Yes, I have pasted, then I have to go to the option, right?
You need to just check if you want to make changes. Otherwise, there is no need. By default, it is
It's
95%.
okay, it's 95, and I have to click to the one option, exclude cases analysis by analysis, right?
Whatever, yeah.
Huh?
This is what the missing values, although there is no missing values in the data, sir. So we will go with the by default option, right?
Right.
Right. So now we can press on OK to generate the output. I think I have pressed it, and I have got the output also. So I think I can explain now. May I?
Ma'am, please tell me what is the missing value? You have earlier told me.
Missing values means the data which is not available with you, that is missing value.
So, ma'am, always it is there is no data available. I mean, there is no missing value.
No, it is not like that one, depending upon your data collection.
Like it is over here, 359 numbers, it means that there is no missing data, right?
Ma'am, usually when we are collecting the data through the Google form, so I think there is a facility available. We can make each and every question mandatory for respondent to answer that, right? So
Yes.
that way, chances are very less that there will be a missing value. But when you are collecting data manually. You are floating the hard copy of your questionnaire. In that case, it is quite possible if the respondents are not comfortable in giving answer of some questions, they can escape it easily. In that case, they will become the missing value for you. But I think nowadays using the Google form, it is little difficult for that. But if we are going for the field survey type of data collection, in that case, it is quite obvious. Okay.
Thank you, ma'am.
Okay, fine, ma'am. So coming here, talking about the paired sample status, we can see here the this is a variable. We can say grade 1 and grade 2. We can say the mean of the grade 1 is 6.01 and the mean of the grade 2 is 7.19. Right now, talking about this total about 359 and 359. That means this is a case of paired sample status, because if these two figures are not same, in that case we cannot apply paired sample status. There should be always a pairing. Right, so that means same number of people should be available in the second group also, or in the second conduct also. These are the standard deviation of the scores or grade, and this is the standard error of mean. Talking about the paired sample t-test, correlation means paired samples correlation. So whenever we are talking about the paired samples t-test, we will always get a 7, although this value is very, very less figure, means there is no relationship between the scores, right? So significant value is also greater than 0.05, right? So we can say this thing that the correlation is, or the relationship is not maintained by your pairs. Talking about the last table, which is giving you the t value and its p value, we can see the mean difference is coming as minus 1.17. Standard deviation of this difference is 0.51668. This is the standard error of mean, and this is the 95% confidence interval of differences, lower and the upper limits, and the t value is minus 43.15. For the degrees of freedom 358, significant value is coming as 0.000, which is less than 0.05, right? So the main section for us is this, that the p value is less than 0.05. So that way we can say we are not going to accept the null hypothesis, and we can conclude this thing, that there is a significant difference in the grades of students before teaching them and after teaching them, right? Or I can say the teaching is effective, right? Why I'm saying teaching is effective? Because you can see this is the first conduct mean and this is the second conduct mean, and we can say in the second conduct mean has increased. So that way we can say that the teaching was effective. Okay.
Right, ma'am. This data
Ma'am,
shows that the improvement is done over there.
There is
After
an
the-
improvement in this course
Yes,
or
there is
grades.
an yes.
Yes, yes, correct. So I think this
ma'am,
is
I
all.
have a doubt, ma'am. Sorry.
Yeah.
Yes, ma'am. Here in correlation, what is the purpose here, and can you please explain again?
Ma'am, usually whenever you are talking about paired sample status, we always get an output whether we are applying through the SPSS or through Excel. In Excel also we are getting this figure. Generally, this says the relationship between your pairs, right? So that means your pairs are independent of each other. But generally, this value should be moderate figure, because here there is no relationship maintained by the pairs, right? Correlation says you the relationship is existing between the variables or not. So here we are having two variables, grade 1 and grade 2, right? Although for the same people we are collecting the grades, so that way we are expecting that there should be some relationship, but this relationship is very weak or poor relationship. Is it fine, ma'am?
Yeah, yes,
Ma'am,
yes. Thank you.
for another example, if I say there is MSc1 and MSc2 in all colleges, right? So
Yes.
in MSc1, these students, they few students couldn't qualify, and thus we conducted their improvement test.
Okay.
And after taking the improvement test, now they are passed or they got good marks. So on that test, this test can be applied na MSc1 on an MSc1 and their improvement t-test.
If same number of students we are using, then we can apply, sir.
Yes, same. Like
Same
if
number
there
of
is
students we are
35
using.
students in one class, then we can do the same.
In that case, you can do. And if you are means usually this happens if you are, say for example, as I said, if I want to check or if I want to give you means, for example, in my teaching, suppose I'm teaching to my class, right? So I have prepared a quiz, I have prepared a test for them. So before teaching, I'm giving a test, and after teaching, I'm repeating the same test, because I want to test whether now the students are able to give the answers of same questions or not. Probably previously they were not. So after teaching, whether they are able to answer those questions or not, right? So that way I can say this is a case of paired sample t-test. On the same number of people or on the same number of students, I'm applying the same test, or I'm repeating the same type of quiz and then collecting
Right.
these scores, right?
Yes, yes, understood.
Yes.
Thank you.
Okay.
Excuse me, madam.
Can be
Yes, sir.
Madam, you had explained some time back the 5 important things those are required when we conduct this test to write in the research paper. Could you please name them again, those 5 things?
Yes, sir. First one was the t value, right? Now
Yes.
the degrees of freedom, then p value, mean difference, and confidence interval of difference.
Yeah, okay. The last one I had missed. Thank you.
Yeah. So confidence interval is this. Usually, I think I haven't explained, nobody has asked me this, but I think now you have told me this, so I'm telling you the meaning of this. Confidence interval means logic behind reporting this is that generally the sign means this lower limit and the upper limit, you need to have the same signs. This is the logic. That way we can say your results are reliable. But if suppose lower limit is positive or upper limit is negative or vice versa, in that case there is a problem in the reliability or trusting of your results.
Yes, madam. The confidence level is low in that case.
Yes.
Thank you.
Yeah. So I think this is all from my side. Now platform is open for all of you. You can ask me queries if you are having any queries.
Madam, one more thing. These videos will be available even after the class, means later on after 1 month, if I'm doing revision, I want to see something.
Will be available on the YouTube of RFI, or also you can refer my YouTube. There is a YouTube channel of mine also, Dr. Chanchalan. There also you can find these things.
It is by name Dr. Chanchala.
Dr. Chanchal. Yeah, not Chanchal. There is Dr. Chanchal only.
Okay. Thank you.
I'm following you, ma'am.
Sorry?
I'm following you on that YouTube link.
Okay.
Your personal YouTube link. Yeah.
Okay. Thank you so much, sir. I think I'm trying, sir. Problem is that I'm also teaching in a college, so sometimes it happens I'm not getting time to shoot or make the videos, because my students are also requesting me, ma'am, please make some videos for us. Exam times is there. Exams are going on in the college, and 23rd is the exam of my subject. So I think before that I'll put some more videos there.
I would love to invite you in my college also. That is PCT Ludhiana.
Okay,
And
definitely.
definitely, if you may shower your that rain of knowledge to the students as well as the faculty members.
I think it is too much to you have said to me, sir. I'm not that much. I do not have that much expertise, but it's still, if you will ask me to come, definitely I'll come.
Definitely, ma'am. Definitely.
Yeah, thank you, sir. Okay, so I think this is all from my side. If you are having any queries, you can ask me. If not, I'll insist. I request everyone to switch on your cameras to capture you people. Ha, Madan sir. Yes.
and which stuff can we use that here?
Madan sir, I'm not getting your voice. There is a problem in your voice.
Ma'am, which graph can we use here
For?
in the test?
Sir, your voice is very low. I'm not able to understand your voice. If you want, you can write in the chat also. There is no problem. I can read from there also. Madan sir, are you writing your query there?
Yes, ma'am. Yes, ma'am.
Okay. Give me a second. I'm capturing everyone. Yes. Captured. Oh, just a minute. Please do not switch on, switch off. I think few more have switch on their cameras. Give me a second. Very good. Thank you. Thank you. Madan sir, have you typed which is the graph we can use here in pair t-test? Sir, why we are using the graph? Why? What is the logic? Why are you asking this question? For what purpose you want to draw a graph for your data? Can you tell me that? Is there any purpose? Means, what is your purpose? Manu sir, I think you can hear me, right? Sorry, Madan sir, you can hear me? Madan sir, am I audible to you?
Yes, ma'am.
Sir, I'm not getting your question. What is the purpose? I think I haven't discussed the graph in that case. We have only seen the histogram for checking the normality. Is it what are you asking?
कई बार ऐसा होता है ना, किसी के रजिस्ट्रेशन में आप यूज कर रहे हो उसको ना, उसमें कैसे यूज करेंगे?
Sorry, I'm not getting you properly. I think there is a very low sound at your end and I cannot hear it properly.
मैम मैं मैसेज करता हूँ मैम.
हाँ जी. In chat, are you messaging? Are you writing on?
Yes, ma'am. Yes, ma'am.
Okay, I'm waiting. I'm waiting, sir. As we have to use it in thesis to see the output. I think output of t-test you cannot show through a graph, sir. How can you show the output of the t-test through the graph? We can only check the assumptions through the graph. Like for outliers, you can use box plot. For normality, you can use histogram. But for output, there is no such graph. I think I haven't studied this thing anywhere so far. Even in my statistics books also, I haven't seen this thing.
Okay.
Manan sir, is it fine?
Yes, ma'am. Yes, ma'am.
I
Okay.
think what we can do, ma'am, that by copying and pasting this graph in our research paper, we can define it.
We can import as the way we can import the data, we can export also. Give me a second, I'll show you how you can export your data. Just a minute.
Yes, please.
Yes. Yes. Say, I think my screen is visible, right? I have shared it again.
Yes.
Is it visible? Right. Suppose I want to export this particular table. I can come here. I can click on this. I can do the right click and you can see export option is coming here. You can click on this export. Similarly, for the graphs also, you can export your data, right? So you can see the first section is asking us objects to export. Whether we want to only export the selected object or whether we want to select all, export all the objects, whether we want to export only visible objects. This is up to us, whatever we want to export, right? Suppose we want to only extract the selected one, right? Coming to next, it is asking us, SPSS is asking us in which format we want to get the exporting of the data, right? So these, by default, it is a doc file in the Word file, or else if you want to change the way in which you want to get your output, so you can select from here, right? But generally, we are taking the output in the document file. Then it is asking you the file name, wherever you want to, so whatever name you want to give to your file. You can see here, it is storing my data in the C program or in the C drive. So if you want to make changes, you can select here the browse, you can click here on the browse button and you can select the location also, right? And at the end, you can write the name of your file. And that way you can, just a minute, I need to shift it here. And you can click on the OK button. Once you will click on OK, your output will be, means whatever output you want to take it from here, it will be exported at that particular location. Is it okay? I hope you got it. I think this is what you was asking. Sorry.
Just a second. I think this question was from Madan, but I'm trying it.
Okay.
Yes, done, ma'am. It's downloaded.
Okay. Okay, sir. Thank you.
Thank you. Thank you.
Yeah. So I hope,
Okay.
Madan sir, you have also got the answer. Probably I would be able to tell you how you can export the data, right? If this was your question. Fine. Madan sir, is it fine now?
Yes, ma'am. Yes, ma'am.
Yes. So I think thank you thank you everyone for joining the workshop on the 5th day. Tomorrow we will meet again, and I think tomorrow we are going to talk about the one-way ANOVA, right? So this is all from my side for the day. Take care, everyone. We will meet tomorrow at the 5:30 p.m. sharp. Thank you, everyone. Anyone from the RFIs here?
Thank you, Chanchala ma'am.
Okay, Ajay sir is there. Okay, Ajay sir. Sir, I am done.
आपकी तबीयत खराब हो रही है आज?
Sir, last 3 दिन से चल रही है सर्दी खांसी एंड फीवर.
चलिए, please take care, ma'am. Thank you so much.
Thank you, sir. Thank you,
Thank you, all
everyone.
participants. Thank you.
Thank you.
Thank you.
Thank you so much,
Sir.
ma'am.
Thank you, ma'am. Take care.
Thank you, ma'am.
Good
Get
night.
well soon.